Hi, everyone, and thanks for joining this session today. I'm Abhinav Puri, and I'm the product manager at SUSE for our container and application platforms portfolio. And I'm joined today by Troy Topnick. Troy?
Hi, I'm Troy. I'm the product manager for SUSE Cloud Application Platform.
Thanks, Troy. So in the next 30 minutes, Troy and I plan to walk you through how you can automate your application development and deployment pipelines. We will introduce the concept of DevOps and CICD and share with you how SUSE technologies will support you in enhancing that automation that you're trying to achieve. Now, before we talk about the what and the how elements of this topic, let's first spend a little time talking about the why. Why is it important for your enterprise to achieve those efficiencies and automation in your application development and deployment pipelines? It is important because irrespective of which business you are in, you need to ensure that your customers are able to seamlessly engage with your organization across multiple channels and touchpoints. This is the era of experiences. And as an organization, you need to be able to deliver those experiences to your customers. Let's say you are a retailer. Then I, the average shopper, expect that I'm able to check stock and availability for whatever I need in real time in every store in my neighborhood. And I expect to be able to do that on my phone. Let's say you are an automotive player. Then I, the average car buyer, expect that I'm able to update the software on my car's infotainment system from a click of a button on my phone, and that I'm not required to haul my car all the way to a service center to do that. And not just that, I am also expecting you to listen to my feedback and make changes to your applications. Those applications that improve the way I engage with whatever service you are providing me. And there are tons and tons of examples of this nature. But what is common across all these examples is that this experience is delivered by an application or a set of applications. And it is these applications that enable you as a business to acquire and retain customers. We are living in a day and age where applications are the core driver of your business success, no matter what your strategic goals are, whether it is cost control or gaining those extra points in market share or establishing key differentiators to your competition. All of that will be driven by your ability to get good applications to production faster. And this is where it starts getting real. The agility that you are trying to achieve in your business will be extremely hard to achieve if you are still developing large monolithic applications and deploying them in traditional waterfall-like models. Your ability to make changes and go to market swiftly will be impacted, which is why you need to modernize your application development and deployment approach. And this modernization will be multifold. It will be multifaceted and multi-cloud. And I'm sure a lot of you are already at different stages of this transformation journey, with the ultimate goal of embracing the DevOps paradigm, deploying containerized applications that are leveraging a microservices-based architecture. All of that allows you to increase your application development frequency, shorten your development life cycles, effectively helping your organization achieve its business objectives. This is the age of DevOps. And DevOps in itself is a paradigm. And CICD are key elements of that paradigm. And that is the focus of our session today. Now, that was the why part of this session. Why is it important for your enterprise to achieve automation and efficiencies in your development and deployment pipelines? Now, let's spend some time talking about the what part. What do we mean when we say CI/CD in the cloud native world? When we say CI, we mean continuous integration. We are talking about the practice of running builds and integration tests whenever code is committed to a repository. With CD, we mean continuous delivery, or in the case of some organizations, continuous deployment, which is the practice of automating the development or deployment of build artifacts into test, staging, or production environments. Now, before we get into specifics of how you can adopt this approach in your organization, let's first spend a moment talking about the different stages in the DevOps paradigm and where does continuous integration, delivery, and deployment fit in. Like I said, DevOps in itself is a paradigm. It describes an organization's culture and practices which enable them to bridge the gap between developers and ops teams. It describes how to improve processes through collaborative and agile workflows. It will help you drive for faster software delivery, achieve consistent governance and control. Now, if we were to transpose this paradigm to different stages of the software development deployment lifecycle, we're talking about CI being the practice in the DevOps paradigm of automating the code, build, and merge phases. Continuous delivery being the practice of automating the test and release phases, with continuous deployment extending that to deployment of your software. And that's not the entirety of this. For most organizations, it is absolutely imperative that security is embedded across this entire life cycle, making the delivery of applications not just faster, but also more secure. And this is not a big bang style of delivery, but smaller, more frequent deliveries. And this is achieved by automating different phases in this whole life cycle, which we now call the DevSecOps life cycle. At a very high level, continuous integration will cover the build, test, and merge phases. Continuous delivery is extending to automatically releasing that software in the designated repository, and continuous deployment is then automatically deploying that piece of software to production. Going a bit more granular, by introducing automation tooling in our deployment development lifecycle, we are effectively automating a large set of steps, thereby ensuring faster and more secure software delivery. Now, that was an overview of the why and the what aspects of what enterprises need to do in order to achieve those efficiencies in their deployment and development pipelines. Now, let's talk about the how aspect. How can you get there and how SUSE technologies can support you in that journey? And for that, let me hand over to Troy. Over to you, Troy.
So I'm the product manager for a platform called the Cloud Application Platform. It is born of a model of platform as a service that is exposing to developers a way to deploy their applications quickly, rapidly, continually using APIs. And there are ways in which platforms for applications are typically combined with CICD to make a workflow for continuous delivery. And here's where that model comes from initially. Here as an example, I'm taking a number of line of business developers who are working on their own workstations. They will often be testing their code on their own workstations. They will have a development environment that runs this code, and when they check that everything is working properly, they commit it to Git. Git in turn will kick off a build process in a CICD system like Jenkins, which is possibly the most widely known CICD system. Jenkins will take a clone of this repository of the code in question, build it, run a series of continuous integration tests on it to ensure that the code is behaving correctly, and then ultimately have an archive or some sort of built package of the software for delivery. This is then stored somewhere for use, and to put this code into production, this is handed off then to another team, somebody with a DevOps title, a release manager title, perhaps a system administrator, and then a customized manual process is usually put in place by which that code is evaluated. Maybe it's operated on by a QA team and then published into production. There are a lot of manual steps in this still, even with the automation that's provided by the connection of source code control and CICD with Git and Jenkins. So one thing we've seen people do is combine this workflow with platform as a service. And in our case, this would be Cloud Application Platform using the Cloud Foundry API. Now, the Cloud Foundry API gives those line of business developers access to an API where they can themselves access compute resources. They can deploy, they can push an application into an environment that is, for all intents and purposes, identical to the production environment. To them, it's a black box. It is an API. They push their code, and magically up comes their application. They will also be committing this code to some kind of source code control repository like Git. What often is done for deploying those applications into a production environment is to run that code through a CICD pipeline, which then, as an end step, as a deploy step, sends the code off to the platform. So a commit with a particular tag going to Git kicks off a build in Jenkins, which runs continuous integration tests from whatever test suite is appropriate for that language or framework. And that is an end step. Instead of packaging the application in a tar file or an RPM, it is actually pushed by the CICD system to the Cloud Foundry API endpoint with the same CF push command that the developers who are using the API directly would use. Then magic happens in the platform black box under the auspices of the administrators, of the DevOps or release manager, people who are in charge of looking after the platform. But still, from the point of view of the developers, it's kind of magic what goes on in there. And there's a lot of magic involved. So here is, believe it or not, a simplified version of what goes on inside a typical Cloud Foundry, or in our case, kubecf, a Kubernetes native Cloud Foundry platform. In this box, there are a lot of different processes, some of which are actually doing the same kinds of things as a CI/CD system would do. We see in the bottom left corner these things, this image for build pack plus stack Docker image users app. This is a lot like what happens when a CI/CD system builds a package, or maybe packages the application as a Docker container. There are a few other things in here, such as logging and log aggregation, that are also done by good CI/CD systems so that people have good visibility onto all of the builds that the system is generating. So when we combine this with CI/CD system, especially a full-featured CI/CD system, we have a lot of duplication. We're essentially building an application, pushing it to a platform which rebuilds it. And that's not ideal. There's wasted effort going on, and there's also a problem with reproducibility. What's going on in the CI/CD pipeline might be slightly different than what happens in a staging environment. So I'd like to look a little more closely at that staging environment, because a lot of people who are not familiar with Cloud Foundry or Heroku or similar platform as a service offerings wouldn't necessarily know what that is. And what staging is in this context is an automated, or I call a magic, build pipeline. Instead of a developer or a release engineer creating a pipeline for a specific application and writing out a series of scripts to build that application, we have in our platform these things called build packs. And build packs are heuristics-driven pipelines. They are generic pipelines that interpret what kind of application is being deployed, what frameworks are being used, which application and language libraries are required, and it chooses, based on these heuristics or based on the definition you've put in a manifest file, what to do with the code that you're giving it. And in the push process, the CF push process, we see this the staging step as duplicating some of what's going on in a good or well-engineered CI/CD pipeline. Staging the app, streaming the output of that staging, the build logs essentially, back to the users or back to the log aggregator, storing the app droplet, or in a more modern context with Cloud Foundry, storing an application container image, OCI container image, and then completing the staging and moving the application into production. So this is the part that is sort of done in two places when you stick the two systems together. And I think it's about time we reduce this duplication. Instead of adding platform as a service as an end step, why don't we expose those parts of the development lifecycle that we can in a safe way using role-based access control that's available in our platform already. Translate the staging process, which does provide logs in a platform, but is not quite as observable as it is in a full-fledged CICD system. We want to have a record of all of the results of these builds, store the artifacts that are created, be they OCI images, the YAML config for deployment, and expose them to the users who did the deploying. We also want to be able to track changes between those deployments and map them back to changes in the code, in the source code control system. In short, we want to make GitOps part of platform as a service. And when we start looking at doing that, we start looking at other systems which are Kubernetes native CI/CD systems, ones that are maybe a little bit more modern than Jenkins, namely Jenkins X. Jenkins X is a complete redesign, more broadly recognized in the market perhaps than the others. It's a CI/CD system for Kubernetes, which under the hood uses another one of these logos, Tekton. Tekton is a framework for building CI/CD systems, so it has a lot of primitives that we can leverage to add CI/CD functionality. This is a project from Google, and the part of this that we're particularly interested in is Tekton pipelines. Another container native CI/CD platform is Drone. Argo is another one, focuses on continuous delivery, not so much continuous integration. And this shows us a model of what can be done with the GitOps mindset. These are the ones we can consider when we want to expand our platform, which we do. So here's a diagram of how things could work. The platform could include, as part of what you deploy, its own Git interface. Developers work, instead of directly with the API, work with Git, and Git communicates with the API or is called through hooks to build and test and package the applications, much as it did before, but as a function of the Cloud Foundry API. In this more modern version, we would use cloud native build packs. This is the icon on the right of that top green box. Cloud native build packs take the principle of build packs, which are a series of scripts which create container images, and they actually provide they are themselves container images which run steps of these generic pipelines. Substituting what would be in a typical Cloud Foundry system, the Diego application scheduler, we have this thing called Irene. Irene replaces Cloud Foundry's legacy container scheduler with an interface to Kubernetes so that the results of this build test package pipeline are actually deployed directly to Kubernetes. It creates automatically Kubernetes config to run these applications as pods. Now these built artifacts from our CI/CD pipeline, our internal CI/CD pipeline, will also end up in a container registry, be it something like Harbor or a Docker registry fronted by Portis, an open SUSE project. The idea here is that the end users who have permissions to this platform will also be able to optionally fetch the container images that are the result of this pipeline. For observability, we can plug in the ELK stack, Elasticsearch stack. Here we have Logstash or FluentD as a logging mechanism, and Elasticsearch is a way to index that, and Kibana as a dashboard. We can allow developers access to log pipelines for their specific deployments, or ones that they are allowed to see through their permissions on the platform. Now, the role of the operator, the system operator in this case, is to look after the platform, not to create individual deployment pipelines or individual deployment environments. They manage the platform, they set the policies for the platform, and then they give API access to the users. So here's what SUSE can do for you to explore this area of technology. Right now, we offer you SUSE CaaS Platform, latest release being 4.2. That's our distribution of Kubernetes, and it provides the container hosting for this model. We have SUSE Cloud Application Platform, our Kubernetes-based Cloud Foundry PaaS, and that gives us the developer interface, the API, and the tooling for developers to use a platform. We do have integration with currently popular CID systems like GitLab and JenkinsX. We've got white papers on these, and that can show you how to combine these, as I showed earlier, putting the platform as an end step. This is a significant savings of effort, and it is a useful model. It's just that we can do one better. One of the shortcuts we can take that I thought is worth mentioning is CF push Docker image. If you have Docker images, if your CICD system can create Docker images, you can actually currently skip the staging step with Cloud Foundry and deploy the Docker image directly to the platform. What we're looking at providing next as extensions to our CaaS platform and Cloud Application Platform is improved observability for the logging and metrics of the system. ELK or EFK, using the Elastic Stack to provide more information to the users of the platform and give us an equivalent to the way that a CI/CD system saves logs for each individual build. We can expose that CI/CD system in the same interface that we currently have for the platform. Both CASP and CAP, CaaS Platform and Cloud Application Platform, have the Stratos interface for Kubernetes and Cloud Foundry, single pane of glass where you can connect numerous API endpoints and get a consolidated view of all your work. We can add to this build pipeline views to reflect the CI/CD workflows. OCI registry and interface, Cloud Foundry already has one built in the latest iteration. We want to expose this to users using the same role-based access control that the rest of the platform uses. We can add a Git interface so that if you don't have your own Git system either in-house or from a service provider, you'll have that in the platform out of the box. And of course, we can combine all of these things to make a tightly integrated workflow so that developers and operators who are using the system can do so easily. Here's where you can find a little more information about these things. SUSE Cloud Application Platform on the SUSE website, likewise the SUSE CaaS platform, and to draw your attention to the SUSE developer community, which has newly been launched. Through this community, you can get access to the Cloud Application Platform sandbox. So without having to install all of the software yourself, you can get an account with a small quota and explore using Platform as a Service and in conjunction with your own CI/CD systems. And that's all we have for today. Thanks so much for watching our SUSECon digital presentation. We hope you enjoyed it as much as we've enjoyed presenting it.
Thank you, everyone.